Now, earlier on, we had a brief look at fuzzy valuation for atomic sentences. And now that we've got the Boolean operators not, or, and in place, it's time to take a look at how valuations work for molecular sentences constructed with these. To begin, let's look at the unary operator, the negative sign, and see how it works first with the Boolean operators, which are, as we saw, binary. We can write these as true or false, or 0 and 1. Here you can see we're just treating 0 as equivalent to false and 1 as equivalent to true. And as we've already seen, the negative sign flips the values so that if phi is valued at 1, then not phi is 0, and vice versa. So let's introduce an operation here to see how this works with fuzzy values. Let's suppose that the value of phi is equal to 0.75. That is to say, phi is 3/4 true or something like that. Then the value of not phi will just be 1 minus the value of phi. So we'll say value not phi is equal to 1 minus 0.75 is 0.25. So then let's write this out more formally so we can just see it. So the valuation of not phi is equal to 1 minus the valuation of phi, but this only applies if the valuation of phi is greater than 0. If the value of phi is 0, then the valuation of not phi is just 1. Intuitively, this just works because as the valuation of phi goes down, it seems like the valuation of its negation should coordinately go up. Now let's look at conjunction. And here again, we'll use zeros and ones to represent f's and t's. So phi and psi will come out true in the first row, false in the second, or 0 in the second, 0 in the third, and 0 in the fourth. And that's just what our table for conjunction looks like. Now, if we have fuzzy truth values that we're dealing with, then the value of phi and psi will be equal to the minimum truth value of the two of them. So suppose that the value of phi is 0.55 and the value of psi is 0.99. Then the minimum of these will just be 0.55, and that is the correct answer for phi and psi. If you want to see how this works intuitively, I find it helps to notice that it actually works for our binary values 1 and 0 as well. So for instance, if we look back at the binary truth table for and, well, what's the minimum of 1 and 1? It's 1, so that's correct. 1 and 0 is 0, that's correct. 0 and 1 also 0. And 0 and 0, the minimum value is 0. So we could have actually used this for our binary values as well. Hence, the way to give the valuation for and is the minimum value of the two. The last thing we want to look at here is disjunction. But before we go on to that, I would encourage you to pause the video for just a second. Think about the fact that we used the minimum truth values to establish the truth table for fuzzy phi and psi valuations, and take a guess at what kind of operation we would use to determine the valuation for phi or psi. So here's our regular binary truth table for phi or psi, and the way that we can cache this out both for this truth table and for the fuzzy valuations is by taking the maximum value. And it's easy to check that this works for the binary truth table as well. So whenever we're talking about the disjunction of the sentences with fuzzy valuations, we're talking about the maximum value of those being the value of the whole thing. And that's how we give truth conditions for the Boolean operators in fuzzy logic. And as I've noted, for both and or conjunction and disjunction, this method works for binary valuations as well.